Hello and welcome to the first part of demonstrating our MSPL for RSWay tool. The tool is a prototype implementation that implements out the steps of our approach as described in our paper. Here is the website of our tool. The MSPL for RSWay is a tool that combines the multiple software product line with the service-oriented architecture paradigms. The goal of the tool is to design an MSPL that includes two dependent SPLs named SPLSP and SPLSP-SC for respectively the service provider and the service consumer. And then this service provider service SPLs are used to generate customized, valid, and consistent service provider and service consumer. We integrate in our tool practical feature model FMSP and FMSC that handle the variability of SPLSP and SPLSC. The tool is composed of two generators, namely SP generator for service provider and SC generator for service consumer. This generator have been developed separately as a jar file, which can be downloaded from here as RAR files. We also provide an Eclipse version named GBoss Developer Studio that we have a little pre-configured to work correctly with our tool and which can be downloaded by here as a RAR file. The SP and SC generator and the service and GBoss Developer Studio Eclipse version have been already downloaded in our desktop. The SP generator includes a jar file that will be used to run the generator. It also includes many jars needed by the generator, such as jars used by the switcher2, the familiar tool, the SAT4G. For example, let's see SAT4G solver, which will be used to edit feature model and also to develop the update and delete operator, and also, for example, the Velocity Apache tool. Okay, it's also include different files, textual files, for example, those related to that we have developed, of course. For example, those related to the Velocity Apache, templated, and many other. Okay, we proceed now to develop our customized service provider. First, we need to run the SP generator jar file. Okay, SP generator here. Okay, let's run this jar. SP generator. Okay, I missed the jar. Okay, the generator is currently loading the required resource. Here the graphical interface of the generator. We first specify the project name, for example SP app application mean. We define the service count of the service provider, C6 for example. Okay, we then specify this for each service the corresponding capability count, 4, 5, 3, 4, okay, and 4 for example, and 5. Okay, and now we specify for each capability the input and output count, for example. Okay, random numbers. Okay, oops. And let's click to this button to generate the FMSP and FMSC, which are here and here. Okay, now the switch model are generated. We go to the next panel now. Okay, yes, This panel illustrates the specialized feature, which are shared features that can be specialized. The essential feature, which are features that must be resolved. The service provider internal feature, the service provider attribute feature, and the service consumer internal feature. Here it is the feature model of the service provider, defined with the familiar tool. And you can also visualize graphically this feature model with the S2T2. And here it is the feature model of the service consumer. Okay. And now we proceed to a specialized feature model SP specialized from FMSP that will describe the variability of the customized service provider to generate. This text corresponds to the feature model of service provider. At this moment, we do not provide the graphical interface to specialize. We plan to implement this graphical interface in our feature network. So, we need to modify this text in order to specialize the FMSP specialize. Okay. For example, let's take the case of the service 1 and its capability 1 and its capability 1. First, we need to give a name for the service. For example, cart. Okay. We need now to give a name to the capability. Get product. Okay. Get product. We specify the communication technology supported by this capability. We choose REST and MOM. We delete SOAP. Okay. We choose the get method, HTTP method for REST. Okay. We delete the transactional communication feature. We choose the reliability communication. The publish subscribe, it must be durable. And etc. We just need to do this textually. Okay. In fact, let's test it now. This button. This button checks the consistency of the FMSP specialized and generates the FMSC update if it is correct. Many errors appeared. For example, the FMSP specialized is not a specialization of FMSP. The variability of this feature must be resolved because they are internal or maybe they are essential feature, and also the feature attribute must be valued, all of them. Okay. In fact, to facilitate and speed the test of our tool, we have developed a functionality that generates a random and valid FMSP specialize. Okay, by clicking on this button, FMSP specialize have been generated. It is correct. Okay, for example here, the communication technology used by the capability 1 are SOAP, REST, MOM. The rest use GET. The reliability is used. The publish subscribe. The durable is optional. Also, many dummy attribute value have been generated. For example, the name of the service name is the same, service name 1. Okay. For example, the type of the input 1 is string, float, integer, and etc. Let's check the consistency of this FM specialize and generate the FMSC update. Okay. It seems the FMS specialize is valid, and now the generator is currently generating the FMSC update. In fact, it will take less than 1 minute, several seconds. Okay. Okay. Now the FMSP specialized collect and the FMSC update is generated. Okay. Oops. Let's close this panel. And based on the FMS specialized, FMSC update is generated. Okay. Which will be used by the service consumer to invoke the services. Based on the FMSP specialized, we now proceed to concurrently generate the source code of the service provider by clicking on this button. Okay. The generated service provider will be based on the will be a Maven project. Of course, it is based on the switchyard 2 ESB. Just take a less than 1 minute. Okay. We recall that we essentially rely on the Apache Velocity tool, which is a Model 2 text template engine to generate the source code of the service provider from FMSP specialize. Okay. The service provider is now generated. Let's see now the generated source code of the service provider. We can close the furniture now. Okay. We go to the service provider generated directory. We go to the generated files generated directory. Okay. As we can see, many directories have been generated. We go to the project directory, and here it is the generated service provider. Okay, and let's now import this project in the Eclipse version, JBoss Developer Studio. Okay, it takes just several seconds. Okay, it is started. File, we click on this, close this panel. File, import Maven, existing Maven projects, and browse. And we go to the SP generator directory, projects, and we click on OK. Finish. Okay. We need just to wait several seconds. Okay. Okay. We can see that no errors have been detected in the service provider. In fact, many packages and files have been generated. Okay. These files. Okay, you just need to wait another moment. Okay. This files contains source code based on Apache Camel API that manage the requirement of the MOM communication technologies. Okay. This composer can be considered as interceptor that implement the requirement of the SOAP and REST communication technologies, REST and SOAP. Okay. Here are the classes of the input data. There are many of them. Okay. Okay. And here are the output classes of the capability. Okay. Here are the resources used by the REST communication technology. Get, post, get, etc. Okay, these classes represent the service implementation of the service provider. Let's see, for example, service 1. Okay, okay, as you can notice, there is many source code generated. Okay, and you inject, we use the EGB and many other technologies. We can notice that this source code integrate to-do commands that tell the service provider developer the places that he or she should modify. In fact, it also manages the state of the capabilities. For example, also we which are here. Okay, this class manage the state of the capability of each capability. Okay, here are transformers used by SOAP communication technology to transform the request and the responses to the appropriate format of. Okay, and here are 3 utility classes. Here are the WSDL files used by SOAP communication technology. Okay, good. Here are the files that will be deployed by the service consumer to consume the services of the service provider, which are the FMSC update with the familiar format and with the familiar and with the ST2T format and EMF format, and also the contract.xml. The contract.xml contain different information such as the MOM configurations, for example the GNDE of the asynchronous queue. Okay, we note that this information are not defined in the FMSC update files. Here are XMLs. Let's see. Okay, here are XML files that configure the MOM communication technology, such as the GND of the queue and also of the publish subscribe feature. Okay, and finally the switchard.xml, which implement the service component architecture SCA of the switchard ESP. In fact, it illustrates the communication technology and configuration used by each service. For example, the service 1 the service 1 supports the SOAP, the MOM and the SOAP and the REST communication technology. And here is the POM.xml files for Maven, and here are the jar used by the service provider. Okay, let's close all of these panels now. Okay, let's close it. We just need now to deploy this generated service provider in the service so it can be invoked by service consumer. First, let's create another one. Okay, first we need to create a new server. We specify the version. Okay, create a new runtime. Next, browse. We specify here the directory path of the service of the server. Here, runtimes gbus. Okay, and it is important also to choose the standalone full.xml as a configuration file for the server, because this file contains the MOM configuration. Okay, everything is right now. Just now I just have now to run the server, start. Okay, we wait several moments. Okay, it's running. Okay, okay, it's started now, and now we have to deploy our generated service provider in this server. Run on server, and we choose our server. Oh, finish. Okay, okay. Just need to run it another time. Stop it. Start. It is a bug in the server, but it's not ours. Okay, it's not deployed. No, it's not. Run as. Started. Yes, it is started now. Maybe it is some bug in the GBoss Developer Studio or in the server. Okay, we have just now finished the first part of demonstrating our MSPL for SOA tool. We invite you to watch the second part that discusses how we can generate a customized and valid service provider which it is consistent with the generating service provider. And thank you for watching.